Hello. Right, as requested, here is a quick video of how to assemble one of the fingers on the new dexterous hand. I'm just going to go as far as the knuckle joint. If you're doing a test finger, it looks like that. There should be a third servo here. And the hand itself is a bit more complex, and I'll get onto that later because there's quite a lot more in there. But Is that working again? Very good. M2 brass insert. This is an M2 cap head, which is, how long is that? I think that's an M6, 6 mil long. Yep, 6 mil long, M6 stainless cap head, M2 washer, some M2 or 2mm stainless steel or steel ground pins, 10 or 12 mils long. There's one there. There's 3 in that section, and there's 2 in that section. And then in the knuckle, in fact, there's some slightly longer ones. Those are 16 that way, and they are 18 that way, but you can probably get away with shorter. And there's also one hidden down inside here, which goes in before the bearings, and that gives you 2 channels, because there are 2 sets of tendons which come out of a finger, and that inner one is also quite short. Sorry, it's not a very good ruler. I think that's probably only an 8 mil. No, maybe get it over 10. So that's 10, that's 16, and these are 18. And before you push the pins in, you might have to run a drill through, just a hand drill with an M2, and that would clean them out. Now I'm assuming you've printed it and that all the prints are clean. This is just a long M2, which is helpful for inserting that brass insert. Now this insert is kept loose because it also retains the end tendon, which causes the last 2 joints to flex. But this insert has been pressed in with heat. So all you do with that, make sure your hole is reasonably clean. Pass your long bolt through the hole, put your insert on the end of it, and then heat it up with a flame just a couple of seconds till it gets hot enough to melt the plastic, and then put it back in. And that will grip very nicely. And that allows you to retain your inserts, and it makes quite a nice strong bond actually, better than I expected. So the way the finger ends up, if I'll show you with the thumb, in fact, is easiest. So the thumb is slightly different in its proportions, but the principle is the same. You've got this, it's actually orange, but you can't really see it. This tendon, this ligament, in fact. So a ligament connects bone to bone, or whatever stands in for bone in a 3D print. And a tendon, which are these longer ones, they go off to a motor. And so I use the same naming configuration as the human hand. And this ligament passes on the top of here, diagonally through there, comes out the bottom, and then it actually wraps back up and gets screwed down there. But the point is that it goes over the top of this one and underneath that one, and this one here goes underneath here and over the top of there, so that when you bend that joint, there's a relationship between this joint and this joint, which is enforced by that ligament. And that's how you remove one of the extra degrees of freedom from the finger. Audio is weird. Thank you for your message. Can you understand me, however? If not, I'll try and plug something in. Don't know? Okay, well, tell me if you can't hear me at all, and I'll plug in a pair of headphones which should have a built-in mic. Yeah, my phone's a bit damaged, to be honest. Thanks, sec. Okay, that's with a mic plugged in. Is the audio any better? Okay, I assume if no one's complaining, but the audio is better. And if not, you just have to follow it visually. Okie dokie, right. So what I start with, in fact, is this is the tip section. Oh, great, thank you. Right, assume it's all cleaned out, which is quite awkward because the tendon comes in the underneath here, and then there's actually a printed clearance space. So it has to wrap around the insert, and there is, I'm not sure you can really even see it there. I might put up a CAD drawing later. But there is space in the print, and so you really have to remove very carefully the material from here. And then what I find works well is if you can get a screwdriver, you can just about see the tip coming through, then you know you're through. And so the way I do this one, where's my long bit of thread gone? Here it is. So you want a reasonable amount of thread, and I am using this stuff, which is Sufex 832, and I give thanks to Mark Satrekian for recommending braids with gore or other kind of PTFE built in. This stuff, I must say, is very good. Lasts a long time, really hard wearing, and it's quite stiff, which is very useful because you can stick it through holes. So I recommend, this is the best one I've ever used. £80 version is 0.45 millimeters thick. So everything is set up for that. You can get it in a range of colours. I use white, just because it's easier to see. And for a typical finger, you're going to want, I don't know, let's say half a metre, that kind of region. And what you'll end up doing at some point is you end up marking it and trimming it off. But as long as you've got plenty, then you've got plenty. So what you need to do with the fingertip is make a loop, and then you're going to use that screwdriver again to push that loop through that hole. Which I may have to, it's a bit hard to do it. I'm looking through the phone to make sure you can see what I'm doing. So you've got it like that. Get your cleaned finger tip. So you've taken off all the little scraggy bits of filament that are left over from printing, you've cleaned out all your holes, and you've managed to clear out the material, which is the support material, which is kind of left inside that hole. And then, as you know, I can do this whilst looking through the phone. Exit. Ta-da! There we go. Right, so now you've got yourself a loop that's passed through. And then from the other side, there we go. So your loop has passed through that little arch. And then afterwards, you see there's a hole here, and there's going to be a 2mm pin which goes through that. And the 2mm pins are really used to spread out the load. So anywhere you've got high loads, like the tendons, connected to the printed plastic, if you have a nice stiff bit of metal in there, it will spread that load out. And I use the same principle to attach this insert. Now the insert will be used to clamp the ligament, which is this bit of slightly damaged. This is a thicker one, this is about 1 millimetre thick. And this is just normal Dyneema. But frankly, you can use anything for that. And that gets clamped down, and then the insert also serves as the anchor for the main tendon, which will run back up down to the motor. So this will go off to a motor. So to pull this in here is a bit of a wiggle. And the way I found works well is you get it like that, and then to give yourself some leverage, screw on an M2. And then what you want to do is then twist it so that it can't get loose. So you make a few loops like that. and you kind of have to do it all at once. So you're going to push that down and pull this at the same time. And work it down. I mean, it should just go with a little pop. Put it there. So press it down against the table whilst pulling those strings. Okay. So now the insert has gone in, and if you've done it correctly, when you pull on one of these, no, it's not quite right. So what I'm going to do, in fact, take that one out, and then from the other side, just to keep it in place. There you go. So let's pull it in. There you go, right. So now you can see, when you pull on one, the other side goes. So the cable, the tendon, is going down, round the back of that brass insert and out the other side. So that forms a very strong join to the fingertip. And it's very efficient because you're using the same fastener for both the ligament and the tendon. And you can just make sure that's all clear like that. And then as the finger bends, you don't want it coming too far forwards. So that's what this first pin is for. So that's going to go into there. And you can see it's touching them, so you just want to make sure that it's clear. And again, just make sure that when you pull one, the other one is still free, and that you haven't accidentally trapped the tendon by the pin as you press it through. And this gives this is good for two reasons actually. It doubles the amount of material you've got, which means you can use a thinner tendon, and fatigue life is strongly linked to the thickness of the tendon, and also allows some load balancing. So once the other end is secured, if there's any differences in where you've set it up, it will simply slide through. So the tendons end up having the same tension all the way down, or on both sides rather, and then this end, when it gets to the servos, it pokes up through the hole, pokes up through one of these holes, and you wrap it around the central screw, and then you just screw it tight, and it secures it. Which also means you don't have to use any knots, which is worth doing because knots are just always a pain. They're hard to adjust, and also they don't look very professional, so I don't like to use knots. Okie dokie. So I know from previous setting up before that this is where it ends up the lengthwise, but when you're doing it yourself, the first one, just make sure you have plenty of slack. You can see the length of the forearm here. So from the fingertip, you're going to need at least 20 centimeters, 30 centimeters. Tendons are going to, all the motors are going to end up back here. So yeah, 1/2 meter length to start with, and then at the end you'll trim it. A little bit of waste, but if you're making one, you can live with that. And you'll probably have had to buy at least 150 yards. So you're not going to run out of this stuff anytime soon. It's about $20 maybe. Can't remember. It's a long time since I bought it. I've got tons of it. Right, so that is a fingertip, which has an insert pressed in and tendons attached, and the first pin put in. And now we're just going to put on a couple of bearings. And if need be, you can again use a torch and just heat up the plastic so they press on nice and clean. Depends how good your prints are. Give them a little sand. on the whole, these are okay. I might modify the design later, so you can retain them with screws or some other method, but so far it's been all right. So the least components the better, and we'll see how we get on with that. Okay, so that prepares your fingertip like that. And that will butt up against, it's not quite symmetrical, you've got a big end, you've got a small end. That will butt up into there. And in fact, all that holds the finger together is the main ligament. Now what you also might notice is that this round here is larger than the one there, which you can see more clearly once there's a bearing on it. So you see here, the central section is larger diameter. And the reason that's done is because it gives you the correct bending angle. When you close your finger, this bends more than that. And in order for the ligament to force that relationship, you can control that with the diameters of these two parts. Okay? So assuming you've pressed in your bearing, your insert there, there's a bearing on each of these, and then there's this section. So tip, all that's called really, middle section and knuckle section. Small end, big end. And again, I tend to heat up these areas. I'm going to run out of batteries apparently. I'll have to go and get a charger for my phone. I tend to heat up these areas and then just use a 10mm drill to make sure that these are nice and smooth and a good fit to receive. Give me a moment, I have to go and get a power source. Okie dokie, right, that should be charging up now. So many cables for modern technology, good God. Right. Where was I? That's a bit awkward, hang set. Okay, right. So we're now going to connect the knuckle, this midsection, and this tip together. And to do that, you need a short length, 16, maybe start off with 20 centimeters because you end up trimming it. And the path of that is that you're going to pass a loop up through that same hole. One loop will then go around here, and that will leave you with, how do I do this now? Hang on a sec. That's been a while. Oh, no, right. So you just stick it through this hole. One strand will be here, one strand will be here. They cross over inside here, and you can see there's a diagonal channel which goes down like that, and there's a diagonal channel which goes across like that. And so the two strings, the two ligaments, well, that's the same piece of material, they cross in the center there, and then they get anchored over here. And once that's done, the whole finger will start to behave like you expect. Okay, so I'll choose a new bit. So you can see this one's quite damaged, so I've used it quite a few times. So I'll just get a new bit. only a 2mm hole. And so it needs to be well cleaned out, otherwise it's going to be a bit awkward to stick these through. But with a new bit of kite line, that's fairly straightforward. And then we're going to undo this. And get our washer. There's now a washer on that. And just get it started. And if you hold it upside down, of course the washer will fall towards the cap head. And you just wrap it around like that. Okay, so now that's your fingertip with the 2 strands. It's a bit longer than it needs to be. Something like that. And what's nice about this is you can then adjust. Once it's all set up, you actually pull. You do these up just a little bit, and then you can pull the cables and get the whole finger set up as you like. Because you can tune the relative starting point. You know, the tips up like this, or you can have them dead straight, but it's largely aesthetic. I think that's going to be about long enough. Let's just double check. Where's the old one? Measure it. Yeah, 9 centimeters. Okay. Well worth investing in a proper pair of Kevlar shears. Very hard work to cut some of these fibres without proper shears. Normal scissors won't do it. So these have got very fine serrations. Okie dokie. Maybe it's more or less the same length. Alright, so that's the tip. Ligaments top and bottom. Tendon ready to go off back into the forearm to be connected to the motor. So now you just keep the tendon out of the way. Right, so there's our mid piece, smaller end, larger end, nicely cleaned up, bit of heat, press in a bit of 10mm steel, drill's the easiest way to do it, and that will keep your surfaces relatively clean. And you simply have to cross your ligaments over. So that one goes through that hole and out the bottom. This one goes in here and pops out there. And that's the ligaments crossed. And you can see when that's pulled up tight. What you should feel with the bearings, there shouldn't be any scraping. If you push them together when you're setting it up, it should feel really quite remarkably smooth. And that's because the only contact is going through the bearings. If it's not, take it to pieces, clean it up, look for extra bits of plastic which are making contact. And again, a lot of that comes down to the printing and the cleanup of the printing. Okay. So now you've got the knuckle section, which goes that way up. Similar thing at this end, you want to make sure that's all nicely cleaned. You can just use a bit of heat, like a lighter or just a little gas torch, and then press a piece of steel into that. 10mm drill is the easiest way to get 10mm steel, unless you have some lying around, press it in. So now, this is the top one, which will simply be anchored directly there. Just pull these pins out, they were just in there to show you where they're going to go. And the bottom one, similar thing, there's a hole there, and you've got to pass it up through that. There we go. Okie dokie. And if you just even pull it by hand, you can see you're starting to get the finger. So these are a bit longer than you need, but that's fine. You're going to trim off afterwards. So you've got another 6mm M6, so M2 by 6mm long, and a washer. Okay, so washer and your screw. And actually very handy. This, in fact, is a Torx driver. So I'm being attacked by a wasp. This is, can you read that? TX6. And rather handily, that will drive the hex in an M2. So you don't have to keep messing around with tools. And I must say I rather like that. It's a happy accident. And all you're going to do is pass a ligament to either side. That might even be easier to start it off. No, I can't remember how to do this either. Yeah, so press those down to there. You want one either side of the screw head, or rather of the threaded section. Alrighty, and then I'll start to bind it all down. Again, make sure they're not pinched. You can pull them, that's good. And so you see, that starts to be, and it's very loose at this point. But that's all that's holding it together, so it needs to be quite tight, otherwise there's not a lot of lateral strength. And again, that's something that might need fixing up later. Might have more sections, but we shall see if that becomes necessary once the whole thing's powered up. So first thing to do is just pull them nice and tight. And just nip it up. Not too tight, just enough it's got a bit of a nip. And then you can pull them individually. And what you'll find as you pull them individually is that one of them will make the tip flex back and one of them will make it flex down. I don't want to show you that. So that's the down one. Why is it not charging? Yeah, so that makes it go down. And you see if I pull this one now, you'll see the tip come up. So that tensions them against each other. So purely by the tension in that ligament, you get that? And you can see there the final angle. This one bends more than that one because the diameter of where that ligament runs is smaller than the diameter of that one. And that controls the relationship between those two angles. And then if the tendon passes beneath these two pins here, and then it goes back through the knuckle section, through the centre of the knuckle, then when that pulls, that closes. Right, I'm going to stop this one here because my phone is still complaining it's running out of battery and I'm not sure what will happen to the stream if it does completely die. So that's how you assemble a finger. I will show you how to do the knuckle in another section, in another stream or video. But for now, that's it.